Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for the instantaneous decoding of conceptual knowledge in the field of civil engineering where study elaborates decoding the earth to build a better world. Guys, today we will see the important question answers related to the engineering geology based on the rock mechanics and the soil mechanics and its characteristics. Here, the question related to the river and its flow, which is the explain types of landform formed by the action of river. Here the question which is related to the landform techniques or the formation of landform, where the rivers are dynamic agents of erosion. Their movement or their moving water removes the transports material by hydraulic action, abrasion attraction and solution, where which produces various erosional landforms depending on the gradient, discharge, load and rock types. Means the lithological characteristics or topographical characteristics are most important to study with reference to or understand with reference to that formation of landform, because the erosion is a continuous action as the water is flowing on the earth surface. Means your answer which is a combination of landform types and its action related to the erosion point of view. Here the process for that erosion is followed likewise from the rainfall or snow melt, then energy of flow, that is the speed or velocity of that flow, then erosion, that is the actual removal of sediments with reference to the flowing of water, then the transportation of that water with reference to sediment, and then here deposition also will carried out, and at the end the formation of landforms after that deposition of sediments. This is the actual erosional procedure which have to be in your answer. Then most important, that is types of landforms, that are the potholes, waterfalls, gorges, river traces, then meanders and river capture. Here these are the six landforms, or we can say that the types with reference to the river of its birth stage, maturity stage and old stage. If we see the river is in its birth stage, then we have to see that waterfalls. With reference to its maturity stage, then rivers are likewise meandering river or meanderness of the river. And if we see the river at the old stage, then we come to know that the whole river is joining to the nearby big river or the seashore or the oceans. So these are actual landforms which are formed by the erosion of action of water with the formation of potholes, where the topographical characteristics like rock mechanics is in the picture. So characteristics of rocks are most important to study in the formation of potholes. If sedimentary rocks are there, then large amount of sediments can travel with respect to water. Likewise, then waterfalls, then gorges, river traces, step-like benches along with the valley sides. In the valley region, we can see that river traces. Here meanderness, in Maharashtra region, we normally see that type of rivers, that is meanders with the deep narrow valley, which results a vertical erosion of lowering the river bed, and common in rejuvenated rivers. Likewise, in the hilly regions we see that type of topography of river capture, that is stream policy. Means that landforms and dominant erosion in different courses of river, which is most important with reference to its upper course, middle course and lower course. Likewise, the upper course where high gradient, that is hilly region where rivers are taking the birth. In middle course there moderate gradient, that means the water is flowing with reference to some gradient. And it lower course, that means low gradient where water which is flowing from so many kilometers to nearby to the oceans. Likewise, here landforms, potholes, waterfalls in the upper course which are explained here, then landforms, river traces and meanderness which are in the middle course. Likewise here, and lower course, low gradient, that is more deposition than erosion. Likewise, the types of landforms are formed based on some techniques of flowing action of river or the topographical characteristics. Here the key points in your answer are most important, that definition of erosion, then state the process which is explained here. Likewise, we have to explain the six landforms with some sketches which is most important to explain, and then we have to add the conclusion at the end. So what is the concluder remark? The rivers Sclub landforms through continuous erosion. The nature of landform changes from vertical erosion in the upper course to the lateral erosion in the middle course. These landforms are important indicators of the stage of rivers which develop, and they are of significance in the engineering geology point of view. So here the marking scheme is explained with reference to the 6 marks point of view. So if that type of question will ask, then you have to go for that type of answer. Then most important question related to the exam point of view, which is based on some geological investigation. The two types, direct investigation and indirect investigation, or we can say that the direct method and indirect method. So question for 6 marks will be asked is that compare direct and indirect method of surface geological investigation of or subsurface geological investigation likewise. So here we see the direct method and indirect method. The techniques that obtain information by making physical access into subsurface, that is the direct method of subsurface investigation, which includes that drilling boreholes, test pits or trenches, then core sampling, then in situ test, plate load test and laboratory test. These are all the direct methods where we can use some machines and we do the activity on the earth surface. On the other hand, that is indirect method where techniques that infer subsurface condition from surface measurements, means we can't use the surface for excavation activity, but we get the information with reference to some advanced techniques just like remote sensing, GIS, GNSS, GPS likewise. So the examples: seismic methods, electrical resistivity method, electromagnetic methods, ground penetrating radar, that is GPR, gravity survey, magnetic survey. These are all based on some GPS GIS techniques, or we can also say that the digital elevation model, digital surface model and digital terrain model point of view. Here the comparison point of view, we see that the direct method and indirect method of geological investigation, which is on the basis of accessibility, information type, accuracy, getting, time, cost required, coverage of the area, disturbances or obstacles for the each and every method, and the suitability or the application point of view. So direct methods, they require excavation, drilling and sampling, but for indirect method, no physical access required, measurements from surface. That is, we get the measurement with reference to some GPS techniques or some sensors techniques. Here accuracy point of view, high accuracy and high reliability in direct method, but on other hand the indirect method, they are relatively less direct, dependent on interpretation point of view. Then time consuming direct methods, faster data acquisition in indirect method. Then cost point of view also, finance generally costly direct methods, but more economical for large areas in indirect method. Here limited area is covered by the direct method, but large area is covered with reference to some grid survey or some continuous survey. Likewise, we compare each and every direct method and indirect method with reference to that parameters. Now, key points of comparison with reference to the process point of view or flowchart point of view, we see that the direct, that is physical access, then sampling and testing point of view, then laboratory analysis, and followed by accurate local information. Means if we are planning to get the sample, then we have to go physically, we have to collect that sample, then sample with reference to its appropriateness like size, shape and requirement for the testing, then that sample is tested in the laboratory, and after that we get the results with reference to our objective, so that we come to know that the accurate local information. Here the direct methods give reliable detailed information at specific points with reference to ground control points, but they are costly and time consuming. On the other hand, the indirect methods are faster and economical for large areas, but the results require interpretation techniques. Means that comparison also have some limitations. Here, the indirect methods working or the line chart for that indirect method point of view, we see that the source, that is seismic activity, we can say that receivers, they are the geophones, and signal recorded, they are the interpreted surface layers with reference to electromagnetic radiations. Here we emitting the rays, each and every ray going deeper, collect the information and replying to the geophones which are on the earth surface, they are the receivers. Likewise, reflection, emission and receiving technique is in continuous action, so that we capture the data and that data will be plotted with reference to the graphical representation or tabulated format or just like required format. So your answer must have to complete the comparison with reference to the parameter with along with the introductory part of direct method and its example and introductory part of indirect method and its example. This is a complementary of flowchart or process you can write in your answer. Just like the 4 marks for comparison, examples direct and indirect method 1 mark and brief concluding statement 1 mark. Owing towards the numerical point of view, there is a numerical, it can be asked or such type of numericals are already asked or frame with reference to the strike or deep point of view or the geological components point of view. Here the numerical is there. Perpendicular distance between the strike line is 4.5 centimeter. The scale of the map is 1 centimeter is equal to 100 meter. Then interval is given 50 meter. Calculate the amount of deep, that is a true deep we have to find. With reference to that 5 marks for that numerical point of view, we have to first write the given which is in the numerical perpendicular distance between two successive strike lines on map, that is small d, that is 4.5 centimeter. With reference to that given, we have to map the view or we have to draw the plan or diagram where we have to mention the north, then the all contours which are in the orange color or we can say the yellow color, and blue color lines are the strike lines. The distance in between two strike line is 4.5 centimeter as a given in the numerical. The scale of map is given 1 centimeter is equal to 100 meter and contour interval is given 50 meter. So this is the actual map view we plotted with reference to the contour, that is 50 meter 100 meter likewise. So here the perpendicular distance between two successive strike lines is 4.5 centimeter on the map. So here we have to calculate the true deep. For that purpose we have to follow the solution of that fourth stage where conversion of map distance into ground distance. We have the scale 1 centimeter equal to 100 meter, then map distance between the strike is 4.5 centimeter, that is small d. So ground distance is equal to 4.5 into 100. So 4.5 is a small d into 100 is a scale. Likewise 450 meter total area covered on the ground in the horizontal direction. Now with reference to vertical interval or rise point of view, we see the contour interval, that is 50 meter. So the vertical interval is 50 meter. Then we have the formula for true deep, that is theta. Tan theta is equal to vertical interval upon horizontal distance between successive strikes line on ground, that is the perpendicular distance between successive strike lines on the ground. Here tan theta, the vertical interval is 50 and the horizontal distance, total horizontal distance is 450 meter. Likewise we get tan theta is equal to 0.11. So we have to do that inverse, theta is equal to tan inverse, we get 6.34 degrees. This is the actual true deep which is mentioned with reference to that. This is the complementary for the explanation point of view. Vertical section perpendicular to the strike where the horizontal distance is 450 meter on ground. With reference to true deep, we have to calculate that vertical height or interval is 50 meter. So that we find that true deep 6.34 degrees Celsius, which is the actual amount of true deep. Or we can say that approximately 6 degree 20 seconds. 6 degree 20 seconds approximately. So the formula for that true deep is the angle made by the bedding plane with horizontal in a vertical section perpendicular to the strike. Then tan theta is equal to likewise. So here the description or the explanation point of view, we have to understand the bedding planes. On a contour map, strike lines represent the outcrop of a horizontal bedding plane at different elevations. The perpendicular distance between two successive strikes lines gives the horizontal distance on the ground between the equal contour levels. Using that trigonometry and the vertical section perpendicular to the strike, true deep is calculated here. So this is the actual marking scheme for that stages. Stay tuned guys. Happy learning.